Okay, I hope this is close enough to see it. We're looking at graphing rational functions today. This is going to be an introduction to limits. A rational function comes from the word, rational comes from the word ratio. And ratio is just a fraction. It's just a fancy way of saying fraction. Functions are fun. No, not really. A function just means that for every input you have an output that can be predicted. I say that functions are predictable. That's one way of explaining them. I'll show you what that means in just a minute. We're going to use the function y equals 1 over x. We say that y is a function of x, and so we use the f of x notation. It means exactly the same thing. The best way to do it is just to jump right in and take some values of x. X is my independent variable, so I can choose any value for x that I want. I'm going to choose 1, nice easy value for x. And 1 divided by 1 is 1. 1, 1 is an ordered pair that is a solution to this function. We like to start with 0 most of the time, but in this particular problem, 0 gives us a trouble. You can't take 1 divided by 0. So 0 is a domain restriction. That's what we call that. I'm going to graph 1, 1. It's located right here on my graph. That point represents a solution to this equation. If I want another solution, I can choose 2 for x. And when x is 2, y is equal to 1/2. That's also a solution to my equation. We want to keep in mind that these points are nothing more than solutions to the equation. 3 gives me 1/3. And 4 gives me 1/4. 1 divided by 4. We can see that no matter how far we go, we're always going to have 1 over a number. And this number is going to get larger and larger and larger. What we say is that when x gets very large, y gets closer and closer and closer to 0. These decimals are getting smaller and smaller. The way that we write this in mathematical notation is we say that x, as x approaches positive infinity, as it gets very, very large, y approaches 0. This is a limit, and formally we write it, the limit as x approaches infinity of this function or this equation is 0. That's why when we draw this, we approach, get closer and closer and closer to this line. This line is the x-axis, but its equation is y equals 0. We call this thing a horizontal asymptote. Y equals 0 is the equation of the x-axis. A lot of people have trouble with that. Because no matter where I go on the x-axis, this point, for example, is the point -1, 0, -2, 0, -3, 0, -4, 0, 0, 0, 1, 0. Notice that y is always 0 on the x-axis. We call this thing our horizontal asymptote, and we're going to go the other way and look at a vertical asymptote. Grab my eraser. By the way, when we draw this, it looks like this. That line is going, that curve, this curve is going to get closer and closer and closer to the x-axis. Again, we call that a horizontal asymptote. Now I'm going to try some other numbers. Sometimes we say in this situation that y is the reciprocal of x, or x is the reciprocal of y. We can also say that they are inversely proportional. Inverse means reciprocal, same thing. Well, notice that if I choose some other values of x, where x is small, like x is 1/2, y happens to be the reciprocal of x. If you need to see that, we end up with 1 divided by 1/2. Notice that I substitute the x value into this function. 1 divided by 1/2 is the same as 1 times 2/1, which just gives me 2. Notice that when x was 2, y was the reciprocal, 2/1/2. When x is 1/2, y is the reciprocal, 2/1. Let's graph that point. When x is 1/3, and let's actually line these up. I can see that now. Y, of course, is 3. We can graph that point. And what happens is as x gets smaller and smaller and smaller, these decimals are getting smaller and smaller, y is getting larger and larger and larger. We say that they are inversely proportional. And as x gets very large, as x gets close to 0, y gets very large. So this time we're looking at approaching 0. As x approaches 0, y approaches positive infinity. As x gets closer and closer to 0, y gets larger and larger. We can write this formally as the limit as x approaches 0. And by the way, we can't let x be exactly equal to 0, but x can get closer and closer and closer to 0. Then y gets closer and closer and closer to positive infinity. This gives us what we call a vertical asymptote. I like to write my vertical asymptote not equal to. Since x cannot be equal to 0, I actually like to write it like that. It's actually an inequality. it tells me that x cannot be 0. And here is that line. Let me put it in green so you can see it a little better. X is not equal to 0 is my vertical asymptote. I literally cannot cross this line. It is a barrier. There are times when we can cross horizontal asymptotes, and we'll see an example of that later. But you can never cross a vertical asymptote because it's a domain restriction. It's another way of saying that x cannot be equal to 0. This line, this vertical line, is the line x equals 0. Again, I like to write it as x is not equal to 0 because I'm not going to ever allow it to happen. And we can do the negatives in the same way that we did the positives. In fact, the only change I need to make, if this is negative, is that I get a negative over here. And if this is negative, I get a negative over here, and so on. There's all my negative values, and this function comes right down here at -1, -1. Oh, did I miss? -1, -1. -2, -1/2. -1/2, -2. And these approaches are similar. Go back, if you haven't done this yet, go back and take a look at my video, Timing is Everything. When you do these problems and you watch a video, you can't watch them as if you're watching the Simpsons cartoon or something. You can't observe and learn that way. It is important that your timing is ahead of me. You have to work, you have to try it yourself, and then follow along as I do it. If you make a mistake or stumble, then you kind of self-correct. Take a look at that video, take a look at my other ones. Hopefully you'll get this. This is just a very beginning ideas of limits as we do approaches. The next example is going to hopefully clarify some of what I mean by approaches and looking at how we approach 0. In this case, we approached 0 from the right, and in this case, we approached 0 from the left, and we got very different answers. So formally, our original one was from the right. That's what this means. We're talking about numbers that are positive, that are just a little tiny bit bigger than 0. We're approaching from this side, and y goes to infinity. When we approach from this side, we approach from the left. We put a little negative on there. And so I did make an error in the beginning. This answer is going to give us negative infinity. And this approach is going to give us positive infinity.